Good day, grade 8 learners, and welcome to our mathematics lesson. My name is Mshumayeli Nyati, and this lesson is proudly brought to you by the Gauteng Department of Education. Today, we are going to be looking at the theorem of Pythagoras, where we expect that by the end of this lesson, you should be able to investigate the relationship between the length of the sides of a right-angled triangle to develop the theorem of Pythagoras. We also expect you to determine whether a triangle is a right-angled triangle or not if the length of the three sides of the triangle is known. And lastly, we expect you to be able to use the theorem of Pythagoras to calculate the missing length in a right-angled triangle, leaving irrational answers in Z form. In our previous grades as well as previous lessons, we looked at squares and square roots of numbers. We also calculated some area of shapes. We also learned how to express numbers in sets, and we also looked at the properties of triangles. So before we start our lesson, I would like us to quickly do the following baseline activity, which will help us remember some of the things that we learned and also prepare us for the lesson ahead. I'm going to give you 5 minutes to do that. When we come back, we'll go through it together. Thank you. Welcome back, grade 8 learners. Remember to interact with us on our WhatsApp number, which is 079 454 9535. Now let's go through our baseline activity together. We've been asked to simplify and leave your answer in set form if necessary. Right, let's start with A. We need to find the square root of 16x squared. Right, so 16x squared is the expression there. So we look for the square root of the coefficient, which is 16, and then we look for the square root of the variable, which is x squared. Right, so which number, when multiplied by itself, gives us 16? It is 4, because 4 times 4 gives us 16. And which number, when multiplied by itself, gives us x squared? It is x, because x times x gives us x squared. Therefore, the square root of 16 x squared is equal to 4x. Even if you multiply 4x times 4x, you're going to get 16x squared. That's for part A. Then for part B, you need to find the square root of 25n squared. We followed the same method we used in A there, where we find the square root of the coefficient, in this case, which is 25, and then find the square root of the variable, which is n squared. Right, so which number, when multiplied by itself, gives us 25? Is 5, because 5 times 5 gives us 25. And which number, when multiplied by itself, gives us n squared? It is n, because n times n gives us n squared. Right, so that is for part B. Now let's move on to 27, right? We can rewrite 27 as the square root of 9 times 3, right? And then from there, we find the square root of 9 separately and the square root of 3. What is the square root of 9? Which number, when multiplied by itself, gives us 9? It is 3. And can you simplify root 3? No, we can't. We can simplify it, but it will be in decimal form. However, we've been told to leave our answer in set form, right? So that is what we meant by set form, right? Now with D, which is 21, can you simplify 21? Can you find the square root of 21? No, we can, but it will be in decimal form. But we have been asked to leave our answer in set form. So we leave it as it is, right? So for those who need to write corrections, I'm going to give you a minute to do that. But let's just define what's said, right? Some numbers involving roots such as root 2 or root 7 cannot be expressed in the form of a fraction. When a square root cannot be simplified, it is called a set. Right. So for examples, example root 27 and 21 there in our baseline activity, we express them as sets. For those who need to write corrections, I'm going to give you a minute to do so. Just copy what is what we have written A, B, C, and D. You can leave this. It's fine. That's just an explanation. So a minute. Let's quickly do our corrections. Thank you. Welcome back, grade 8 learners. Remember to interact with us on our WhatsApp number, which is 079-454-9535. Now let's have a look at some of the important terms that will help us understand our lesson. The first one is the theorem of Pythagoras, which states that the square of the hypotenuse is equal to the sum of the squares of other two sides. Right. I know at this point in time you might not understand what it really means, but we are going to be having a lot of examples as we progress with our lesson. You'll understand it much better. Right. Then we do have the hypotenuse. The hypotenuse is the side opposite the right angle in a right-angled triangle. And then we do have a set. These are numbers that cannot be expressed as a fraction of two integers and are written using a root sign, for example, root 3. Remember, we express some of our answers in set form when we were doing our baseline activity. Now let's begin our lesson. Right. If a triangle has a right angle, we all know a right angle, right? In this case, is indicated by that sign, right? Then the area of the square with a side on the hypotenuse is equal to the sum of the areas of the square on the other two sides. Right. Let's quickly go through this together. Right. If you check side A, C, how many squares do we have there? This side, if you count, 1, 2, 3, 4. We've got 4 squares, right? And this side, how many squares do we have? We've got 4 squares, right? And this side, how many squares do we have? BC is 3 and 3, right? And this side, how many squares do we have? If you count 1, 2, 3, 4, 5, we do have 5 squares there and 5 squares there. And for us to find the area of a square, what do? We know that it is side times side. So what are we saying? We are saying that if a triangle has a right angle, like this one, triangle ABC has a right angle, then the area of the square with a side on the hypotenuse, this is the hypotenuse, we say the hypotenuse, it is what? It is the side opposite a right angle in a right angle triangle, right? And the right angle triangle, which is 90 degrees, is the largest angle in a right angle triangle. So this side opposite the right angle is called the hypotenuse, right? So the area of the square with a side on the hypotenuse is equal to the sum of the areas of the squares on the other side. So what do we mean? We mean that AC squared, right? AC squared plus BC squared, AC squared, which is this side, plus BC squared, which is that one, should be equal to AC squared, which is the hypotenuse. Right. So let's have a look at that in detail. Right. We can shorten what we had written earlier on and write it in this form, which is the theorem of Pythagoras, which states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Remember, we said this side is 4, this side is 4, this side is 3, this side is 3, this side is 5, this side is 5. So if we say AC squared is 4 squared, right? That is the area, which gives us what? 16, right? That is the area of AC squared. And then we do have the area of BC squared is 3 squared, which gives us what? 9. And then if we add those two, right, which is 16, which will give us 16 plus 9 gives us 25. Right, if we calculate the area of the hypotenuse, right, the square of the hypotenuse, sorry, which is the side opposite the right angle, it will be 5 squared, which is equal to 25. And what can we say? We can conclude that indeed AC squared plus BC squared is equal to AB squared. And that is what we call the theorem of Pythagoras, which states that the square of the hypotenuse, right? The hypotenuse is the longest side in a right-angled triangle, and it is opposite the right-angled triangle, right? The square of the hypotenuse is equal to the sum. The sum meaning we're adding the squares of the other two sides. So just like we did there, AC squared is equal to 4 squared, which will be equal to 16. BC squared is equal to 3 squared, which is equal to 9. If we add the sum of those squares, which is 16 plus 9, gives us 25. And it is equal to the square of the hypotenuse. Right. As we progress with our lesson, we are going to understand this theorem much better. Right. Now, let's move on to another example. With this one, I'm going to help you count, because you might not be able to count the number of squares we have there, right? This side, how many squares do we have? 1, 2, 3, 4, 5. Right, so it is 5 times 5. BC is 5 times 5, and AC has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 times 12. Right. So, and we are told that this is the fact that there is this sign, it shows that it is a right angle triangle. So it means that the sum of the squares of these two sides, which is AC and BC, should be equal to the square of AB. Let's calculate that. 12 squared plus 5 squared gives us what? 12 squared is 144. 5 squared is what? Is 25. If we add those two, the sum of the two squares, it gives us 169. And then AB has got how many squares there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13 and 13 this side. So if we are to square AB, which is 13 squared, it gives us what? 169, which once again proves that in a right angle triangle, right, the square of the hypotenuse is equal to the sum of the squares of the other two sides, which is the theorem of Pythagoras. Right. Now, I would like us to have a look at some of the features, right, that we need to know if we are dealing with the theorem of Pythagoras. Right. The theorem of Pythagoras is used to find the third side in any right angle triangle, right? It is used to find the third side in any right angle triangle, as long as you are given the other two sides. It's not always the case that you are looking for the hypotenuse, right? And in a right angle triangle, the largest angle, which is equal to 90 degrees, right? The largest angle, which is equal to 90 degrees, is always opposite the largest side is always opposite the right angle triangle, and we call that side what? The hypotenuse. We had already mentioned it, right? So this side will be our hypotenuse. It is always opposite the largest angle, which is what? 90 degrees in a right angle triangle. We'll be only dealing with what? With a right angle triangle. And also remember that the theorem of Pythagoras only applies to right angled triangles. Right. Now I think it's time we do a couple of examples to see if you understood what the theorem of Pythagoras entails. Right. And we need to note that a triangle with no right angle does not have hypotenuse altogether. If a triangle does not have a right angle, it does not have a hypotenuse. We don't call that side a hypotenuse, right? Now I'd like us to do the following example, right? We've been asked to answer the following questions using the triangles below. The first question is, which letter represents the hypotenuse in the triangles in the above figures, right? So which letter represents the hypotenuse in the triangles in the above figures, right? So I'm going to give you 3 minutes to quickly write the letter which represents the hypotenuse in figure 1, figure 2, and figure 3. Let's quickly do that. Welcome back, grade 8 learners. Remember to interact with us on our WhatsApp number, which is 079-454-9535. Right, let's go through our example together. We've been asked to identify the letters that represent the hypotenuse in the triangles in the above figures. Right, what did we say? We have, I think for numerous times, we tried to define what an hypotenuse is. We say the hypotenuse is the side that is opposite the right angle in a right angle triangle, right? So in this case, our hypotenuse in figure 1, that is the side which represents the hypotenuse, and it is represented by letter Y in figure 1. Then in figure 2, right, that is the side which represents the hypotenuse, which is what? Which is Q. And in figure 3, that is the letter that represents the hypotenuse, which is what? Which is E. I know from now on you won't forget what the hypotenuse is. It is the side opposite the right angle in a right angle triangle, and it is also the longest side. Remember, when dealt with triangles, we learned that the longest side is opposite the biggest angle, right? So here, the largest angle is what? Is 90 degrees. Therefore, the side opposite it, which is the hypotenuse, is the longest side. Now, let's move on to part B, where we've been asked to write down the Pythagorean equation of each of the triangles above. Right, I'm going to give you an example using this triangle. It is a right angle triangle. Okay, here I've got A, I've got B, I've got C. What do you expect? What you are needed to do by writing the Pythagorean theorem is this one. In this case, if I say A squared, if I write A squared plus B squared is equal to C squared. That's what I expect you to write in these examples. I've given you an example there, which I've got the sides A, B, and C. C is the hypotenuse, and what did you say? If in a right angle triangle, the sum of the other two sides, the sum of the squares of the other two sides is equal to the square of the hypotenuse. So let's quickly write the Pythagorean equation of each of the triangles above. Figure 1, 2, and 3. Once again, I'm going to give you 3 minutes to do that. When we come back, we'll go through it together. Thank you. Welcome back, grade 8 learners. Please remember to interact with us on our WhatsApp number, which is 079 454 9535. Let's go through our example together, where we've been asked to write down the Pythagorean equation of each of the triangles above. I've given you an example there, right, where I had a triangle ABC, and then I wrote my Pythagorean equation as a squared plus b squared is equal to c squared. Right, with figure 1, my Pythagorean equation is x squared plus z squared is equal to y squared. Right, that is my Pythagorean equation for figure 1. Right, I know some might have written it as y squared is equal to z squared plus x squared. What is important is to have the sum of the two shorter side on one side and the sum of the square of the two shorter side on one side and the square of the hypotenuse on the other side. That's what is important. Right. Then with figure 2, my Pythagorean equation is p squared plus r squared is equal to q squared. And then lastly, with figure 3, my Pythagorean equation is d squared plus f squared is equal to e squared. All right. Now that we have learned quite a bit about the theorem of Pythagoras, I would like us to do the following class activity. Right. Okay, let's do this example first before we move on to the class activity. This example, we have been asked to determine whether or not the following triangle is right-angled. Right, so what do you think we should do there? We apply our Pythagoras theorem, right? So if we check there, what we need to note is that if a triangle is a right-angled triangle, right? If a triangle is a right-angled triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides. So if we check there, our longest side is what? The longest side is what? Is 12 centimeters, right? So if this triangle is a right-angled triangle, let me just draw a sketch. 12, maybe, yeah, 9 centimeters, 12 centimeters, and 7 centimeters, right? If we square these two sides, 9 centimeters plus 7 centimeters, it should give us the same value as when we square 12 centimeters. So let's do that. 7 squared plus 9 squared, what do we get? It is 49 plus 81, which gives us 130, right? And then the longest side, which is 12 squared, if you square it, what do we get? It's 144. So what's the conclusion there? Did we get the same answer there? No, we didn't. So now what were we required to find? We were required to determine whether or not the following triangle is a right-angled triangle. Therefore, we can come to the conclusion that 7 squared plus 9 squared is not equal to 12 squared, because 7 squared is 130, yet 12 squared is 144, which means the triangle is not right-angled. I hope you are following there, right? The fact that we didn't get the same values when we squared the other two sides and added them and compared it, with the square of the longer side. The fact that we got different values means that this triangle is not a right-angled triangle, right? I hope you are following there. Remember to interact with us on our WhatsApp line, which is 079 454 9535. You can send us in any questions. We've got a team of dedicated teachers this side who will answer you and can also take your questions. Now, I'd like us to do another example where we have been asked to calculate the length of AC and leave your answer in set form if necessary. Right. What can we note with this triangle? It is a right-angled triangle. The fact that it is a right-angled triangle and we have got two of the sides, it means we can use the Pythagoras theorem to find the other unknown side. In this case, which is the hypotenuse. Why do we say it is the hypotenuse? Because it is opposite the right angle, right? And it is also the longest side. So applying our theorem of Pythagoras, we will note that AC squared, which is the hypotenuse, is equal to AB squared plus BC squared. We have the values of AB and BC. If we substitute that, we're going to get 3 centimeters squared plus 4 centimeters squared. Remember, if you're squaring, you're also going to square the units, right? If you square the units, you're going to get AC squared is equal to 9 centimeters squared plus 16 centimeters squared. If we add that, we are going to get 25 centimeters squared. And for us to find the length of AC, we need to find the square root of 25 centimeters squared. Right. So the square root of 25 is what? Remember, we did that in our baseline. It is 5 because 5 times 5 gives us 25, sorry. And the square root of centimeter squared is what? In centimeters. Therefore, our AC is equal to 5 centimeters. If you want, you can actually prove it, right? Because 5 squared gives us what? 25. And 3 squared plus 3 squared plus 9 squared gives us what? 3 squared plus 4 squared gives us 9 plus 16, which gives us 25. Right. I hope you are following there. Right, learners, please don't forget to interact with us on our WhatsApp number, which is 079 454 9535. Let's do another example. Once again, we need to find the hypotenuse, right? And how do you identify the hypotenuse? It is the side opposite the right angle. Using the theorem of Pythagoras, we can state that AC squared is equal to AB squared plus BC squared, right? And we do have the values of AB. AB is 3 centimeters squared plus 5 centimeters squared, right? And if we simplify that, we're going to get 9 centimeters squared plus 25 centimeters squared. If we add that, we're going to get 34 centimeters squared. And for us to find the value of AC, we need to find the square root of 34, right? We found the square root of centimeter squared. The square root of centimeter squared is centimeters, and the square root of 34. Can we easily simplify that? No, we can't. So we will leave our answer in set form. Remember, the question directed us to leave our answers in set form if necessary, right? So there is no need for you to, I know you can express this in decimal form where you can maybe express it to 2 decimal places, but that would not be correct because the question requires you to leave your answer in set form. So you need to be careful there with the instructions given. Right. Now, I would like us to do the following class activity where we have been asked to calculate the length of AC and leave your answer in set form if necessary. Right. I'm going to give you 3 minutes to do that. When we come back, we'll go through our class activity together. Thank you. Welcome back, grade 8 learners. Remember to interact with us on our WhatsApp number, which is 079-454-9535. Now let's go through our class activity together. Right, we are given a right angle triangle there, and we have to calculate the length of AC, which is our hypotenuse. So we state our Pythagoras theorem there, which is AC squared plus AB squared. AC squared is equal to AB squared plus BC squared. We have the length of AB and BC. If you substitute there, our AB is going to be 8 centimeters squared, plus our BC, which is 15 centimeters, everything squared. Then if you simplify further there, 8 centimeters squared is 64 centimeters squared, and 15 centimeters squared is 225 centimeters squared. If we add that, we are going to get 289. And for us to get AC, we need to find the square root of 289. Can we get it then? Do you get a whole number? Yes, we get a whole number. It's equal to 17 centimeters. Just in case you need to write corrections, let's quickly do so. I'm going to give you a minute before we move on with our lesson. Thank you. Welcome back, grade 8 learners. Now let's continue with our lesson. I'd like us to do the following example. This time, we are given the hypotenuse and another side. We need to find the other side. If you check in our previous examples, we were only calculating the hypotenuse. So this time we have been asked to find the length of the unknown side in the following right angle triangle. We still apply our Pythagoras theorem. Right, if you have to apply our Pythagoras theorem there, our hypotenuse is what? Is 15 centimeters. So if you square the 15 centimeters, it will give us A squared, which is the unknown side, plus 12 centimeters squared. Now using our knowledge of solving equations, what do? Let's first simplify the 15 centimeters squared. We are going to have 225 centimeters squared plus A squared plus 144 centimeters squared. Using our knowledge of solving equations, what do? We apply our additive inverse so that we remain with A squared on the other side. So A squared plus 144 centimeters squared minus 144 centimeters squared. You remember where we applied our additive inverses. So it's 144 centimeters squared there. Sorry, right. Now this simplifies to 144 centimeters squared minus 144 centimeters squared. Then we're going to remain with 225 centimeters squared minus 144 centimeters squared is equal to A squared. If we simplify that further, we are going to get 81 centimeters squared is equal to A squared. For us to find the value of A, what do? We find the square root of 81 centimeters squared, right? So we apply the square root sign on both sides. The square root of A squared is A, and the square root of 81 centimeters squared is what? Is 9 centimeters. Therefore, the unknown side is equal to 9 centimeters. Now, I to have applied what we have just learned to answer the following questions. I'm going to give you 5 minutes to do that. When you come back, we are going to go through it together. Thank you. Welcome back, grade 8 learners. Please remember to interact with us on our WhatsApp number, which is 079-454-9535. Now let's go through our class activity together. Let's start off with the first question, where we've been asked to calculate the missing length in the following triangles, and you need to leave your answer in said form if necessary. Right, as you can see there, we do have our right angle triangle, and what are we given? We're given two sides. One of the sides is the hypotenuse, and we've been asked to find A. So using the theorem of Pythagoras, we can state that 10 centimeters squared is equal to A squared plus 6 centimeters squared. If you simplify that, 10 centimeters squared gives us what? 100 centimeters squared plus is equal to A squared plus 6 centimeters squared is 36 centimeters squared. Then applying our knowledge of solving equations, if it's 100 centimeters squared minus 36 centimeters squared, we apply the additive inverse of 36, which is negative 36 centimeters squared, right? So that we remain with what? With A squared. This simplifies to 0, and the side will remain with 100 centimeters squared minus 36 centimeters squared is equal to A squared. And from there, this will simplify it. We're going to get 64 centimeters squared is equal to A squared. Then we find the square root of both sides, which will give us the value of A. The square root of A squared is A, and the square root of 64 centimeters squared is what? Is 8. Therefore, our A will be equal to 8 centimeters. Right, for those who need to write corrections, let's quickly do so. I'm going to give you a minute to do that. When we come back, we'll move on to the second question. Thank you. Welcome back, great learners. Now let's move on to our second question. Once again, we've been asked to find the missing length and leave our answer in set form if necessary, right? So we do have our right angle triangle. So for us to find the missing side, we need to use the theorem of Pythagoras. We are given our hypotenuse, which is 15 centimeters, and the other side, which is 12 centimeters, and we need to calculate the value of y. So if we state our Pythagoras theorem there, we are going to have 15 centimeters squared is equal to y squared plus 12 centimeters squared, and if you simplify that, we are going to get 225 centimeters squared is equal to y squared plus 144 centimeters squared, right? And then applying the additive inverse there, right, both sides, right, we will remain with 225 centimeters squared is minus 144 centimeters squared is equal to y squared, right? If you simplify there on our left hand side, you're going to get 81 centimeters squared is equal to y squared. And if we apply the square root sign to both sides, we are going to find the square root of 81 centimeters squared and the square root of y squared. The square root of y squared is y, and the square root of 81 centimeters squared is 9 centimeters. So the value of y will be equal to 9 centimeters. And for those who need to write corrections, let's quickly do so. I'm going to give you a minute before we move on with our lesson. Welcome back, grade 8 learners. Now I would like us to copy the following homework, as I always emphasize that in mathematics, the more we practice, the better we become, and we're also going to enjoy the subject. So let's quickly copy the following homework, or you can take a screenshot, right? And please do your homework. Your teacher is going to check if you manage to get the answers correct. So I'm going to give you 2 minutes to do that. When we come back, we'll summarize our lesson. Thank you. Welcome back, grade 8 learners. Now let's summarize our lesson. What is it that we learned today? We learned that in a right angle triangle, the square of the longest side, which is the hypotenuse, is equal to the sum of the squares on the other two sides. And this is called the theorem of Pythagoras. And we can write it as a squared plus b squared is equal to c squared, where c will be our hypotenuse, right? And the theorem of Pythagoras is used to find the third side in any right angle triangle, right? And if a triangle is a right angle triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the length of the other two sides. I really hope you enjoyed this lesson. I didn't receive any WhatsApp question. I suppose that means you understood. Until we meet again in our next live lesson, where we're going to be using appropriate formula to calculate perimeter and area of shapes. Until then, please stay safe and study hard. And would like to thank the Gauteng Department of Education for offering us this opportunity. Goodbye and thank you.